Yes, this topic we have already started, Juno's monitoring and troubleshooting. Now we will revisit this topic and then we'll move ahead for IPv6. IPv6 also we have started in the last sessions, but we have not completed all the configuration of IPv6. So after completing this Juno's monitoring and troubleshooting commands, then we'll move toward IPv6. Okay. So let's start with the very basic commands like ping. Ping we know from the Juniper point of view. If we run ping, we have to break it as a Linux command. In the Linux also we have to break ourselves the output of the ping. Right? Like if I ping to 8.8.8.8 in the operational mode, right? So unless and until I press Control C, it keeps on sending ICMP packets to 8.8.8. Where is 8.8.8 exactly? It's actually here on the ISP router. Loopback interface is configured with this IP address. Right? But if we want to break this, we can break it with Control C. And if you want to run the same command with rapid option, it is possible. Then it gives the output just like a Cisco, right? Where we have 5 ICMP packets going toward the target and we get the reply. Then there is a trace route and trace route monitor option. Trace route we know.
Vision там человек, короче, в общем там.
So if we go to trace route from 8.8.8.8, there is only one hop because as per the topology, only one hop we have to cross and then we can reach to the destination. And if you want to monitor all the intermediate hops, you can have a monitor option under this. So the exact syntax goes like this, and on every second, this information keeps on updating, like how much time we are taking to reach to this target. Command is trace route monitor 8.8.8.8. Then we have logs and monitoring related commands. So where the logs files are available, so it is under var log. So if you want to check where exactly the files are present, you can run a command file list the var log. Right? So all the logs files are available here, and the one of the major file or most important file is the message file. Okay. So if you want to check the message content of message file, you can run a command show log message. So it gives logs messages, but this file is very big file. You can see here. I keeps on pressing enter and then it goes with 1%, right? So it is too much information. If you want to see the latest logs entries in the message file, we can go with last 5 option like this. So last 5 lines will be visible. And if you want to see the boot related messages, so show system boot messages is the command. all booting messages will be displayed here. At the time of booting, whatever message displayed, that will be visible with this command. If we want to set a syslog server, so this is a command, set system syslog. This I have already done in my configuration, so I can show you. Show configuration, right? So all system related configuration is visible, and one of the configuration is syslog, and under this we have host, right? And any facility with the severity level of info. Okay. So I kept 192.168.147.1, which is my laptop IP address. This one, VMnet 8. And I'm running here a Kiwi syslog server. But unfortunately, this is not showing any result of syslog messages. I think the connectivity between the base machine, I'm able to ping here to this IP address, but here you can see the different facilities that we can send messages from. And after that, we have, for example, the facilities in any facility, whether it is a kernel related messages, whether it is a firewall related messages, I want to send this information, right? And with what severity level? So severity levels, the highest severity level is emergency and critical, right? And the lower severity level is like info and warning. So I kept it on lower level. So from lower to higher, all levels messages will get uh, transferred to the syslog server with this IP. Maybe this could be an issue with the firewall. I need to check. Is the Windows firewall. Beside this, we have interface monitoring with monitor interface command. So we can check this with you. Let's go get back to the operational mode, and we can run monitor interface. According to our diagram, the traffic is visible here. In we can see the traffic from GE001 and GE000. So let's test the traffic on interface GE000. Okay, and we will generate some traffic from VPC4. Yes, visible. Okay, VPC4 is already here. Restart the session. It's still not working properly. Okay, now let's ping to 8.8.8.8, which is IP address on the ISP. And because of this, we should see some traffic going back and forth from this VMX router. Let's generate gain few more traffic. This is not showing a result as per expectation. Let's try it with GE001. Okay. Let's see. Now we can see here the traffic counters in terms of input byte and output bytes has been increased here. This is not a production interface, otherwise we can see lots of data going back and forth from the interface, right? Likewise, we can see all the interfaces traffic with monitor interface traffic. Here we are seeing only GE001 interface traffic. Now let's see the monitor interface traffic for all the interfaces. So the interfaces that we are using is GE000 and GE001. Let's try now. Do we have any continuous ping option? Okay, we have count option. GE000 and GE001. You can see the packet counts will increase, right? In terms of input and output, these counters are increasing. So we can check the traffic flow on a particular interfaces. So if you want to trace out which interfaces are actively participating in the data transmission, we can check it by putting a load on the particular flow of traffic like this. We can get the TCP dump kind of information also from the monitor traffic interface on a particular interface. Let's try that. So whatever traffic is going back and forth from this interface will get captured, right? And here by default capture size is 96 byte. We can increase this or we can redirect this file to some other, redirect the output from the terminal to some other file. It's not giving the correct result as per expectation. Let's see. Then these chassis command also we have seen in the past. Show chassis alarm, environment, temperature, hardware, FPC for a particular interface group, cluster, routing engine. Then we have show system commands like show system code, core dumps, alarms, right? These commands can be tried on a VMX router, right? Show system uptime, storage. The show system uptime and storage we have seen in the past, right? License also we can see. This is a virtual machine, so we will not get any specific license number or serial number here. You can see here, install license, 100 scale subscriber, how many IPs can be taken from this. This is like a, here we will see some serial numbers, but here this is a generic router for the test purpose. The request commands we have like system halt, request system halt, power off. If you want to upgrade the software with particular package, that can also be possible. We can have a routing engine switch from RE0 to RE1 if we have chassis with multiple routing engine. We can have a rescue files created, deleted, and roll back with this command. This is used for the tag support. Guys, I hope you know what is tag. If not, please tell me in the chat. Do you know what is tag? What is a JTAG? Where we need this? Correct, Ganesh. It's a support center. Can we use it for our lab purpose? This is only for the purchase license hardware devices and software devices also if we have a license copy. Okay. In the lab, we are using it as a evaluation copy, or we are using it as a test copy, right? So, and here we don't have any uh, special issues on the devices, but in the production environment, if you have purchased a license, you can log a ticket with the JTAG support center, right? And that time they will ask you some information. So beforehand, you can provide this information to them in the form of archive folders, right? So this is TGZZ, right? Correct, Akshay. Serial number is also required, and these files will help the tech engineers to resolve your issues. Exactly what's happening. It's like uh, a black box of your cockpit of the airplane. So whatever information is there that gets collected and will be given to the support engineers or support guys, they will help you with the correct information, or they will try to solve your issues. The slide is not fully ready, so I'll share the slide on in the PDF format. Okay. Now let's get back to the yesterday's topic. We started with the IPv6. Not yesterday, day before yesterday. Unfortunately, I could not manage to take your yesterday's session. So we'll complete this now. So first of all, we will discuss why IPv6 is required, and for that we will have a comparison between IPv4 and IPv6. Right? So if you just have a cursory look on IPv4 and IPv6, which protocol has less number of fields? IPv4 has a less number of fields, or IPv6 header has less number of fields? If you look at the IPv4, we have more number of fields, and in IPv6 we have less number of fields. Some of the fields are common also, like this color, the cyan color is showing as a common fields, right? Then some of the fields are removed, like we don't have identification flags and fragment offset, right? In IPv6 we don't have these fields because fragmentation is avoided in IPv6, and if it is required we have to do it at the start or at the source of the session or at the source of the communication, right? Then this TOS is there, type of service. In IPv4 here we have traffic class, which is like a change with the name and position is changed, right? We do have payload length, and here we have header uh, header length and the total length. There is a header length option also, but I think it's not shown here. Total length is there in IPv4, but here in IPv6 we just have payload length. Why? Because in IPv6 we have fixed header. In IPv4, the header is not fixed. If we have options added, then that header field or header length should also be known to the intermediate processing devices. So if less number of fields are there, the processing will become faster, right? And that's the advantage of IPv6. Why the IPv6 addresses are required? Because IPv4 addresses are exhausted long back in 2013 or I think 2011. I'm not sure about, but some articles are there. It's like exhausting, and by 2019 I think we don't have even a single IPv4 address available. All the addresses are consumed by the consumers, and if you need it, you can get it from the ISP service provider, not from the INA control all this, but INA has already leased out all these IP addresses. Okay. How many addresses we will get? So if we have IPv4 addresses 2 to the power 32, it comes out to be 4 billion IP addresses, but the world population itself is more than 4 billion. It's around 8 billion, right? So you will not get one IP per person theoretically also, because some of the address ranges are reserved. Whereas in 128-bit IPv6 address, you have so many addresses, 3.4 into 10 raised to 38. It means we have 2 to the power 95 addresses per person. So we'll not have any exhaustion on the IPv6 address in a near future. IPv6 address type, we have unicast, we have multicast, and we have anycast. One that was there in IPv4 is now removed. Can you point out or figure out? Correct, Ganesh. Broadcast is removed. But if for any communication broadcast kind of traffic is required, then multicast can be utilized in a manipulated way. But straight away broadcast is not there, and broadcast is not good from the communication perspective, because broadcast generate lots of noise, and that is not good for the security, that is not good for the performance of the network. Then address notations, we can take consecutive zeros and put double colon there, and if there is any leading zeros, that can also be removed. Then there is a concept of prefix notation, just like a network prefix. Here we have prefix notation, and normally it is /64. Means if you take 128, so initial 64 bit is used as a network prefix, and it is denoted like this /64. This some of the prefixes are reserved, like colon /128, right? So this is unspecified IP address. It means we don't have 0000, all 128 zeros. So it is represented it like this. If you have colon /1, it represents loopback address. FF00 represent multicast, and FE80 represent link local addresses. What is link local address? So within a link only it can be utilized, and for that purpose we have to utilize the MAC addresses. Initial 10 bits are with this sequence, and that represent FE8, and the rest of the 54 bits from your network is all 54 bits are represented as zeros, right? So this is how FE80 colon is represented, and then rest of the address, IPv6 address, is coming from a special arrangement of the hardware property. Do you know, guys, how this interface ID is coming? Correct. Ganesh has given a hint on this EUI64. Anyone know what is EUI64 or what is the role of this? Is from where we are getting this interface ID or this host portion of the IPv6 address? Correct. So it is coming from your MAC address, right? And let me show you. Yeah. So this MAC address is actually 48-bit, and in that 48-bit also the first 24 bits is a company ID, and the last 24-bit is manufacturer extension ID, right? You can see here one of the MAC addresses shown here 0010A4A669D0. So if you divide them into two halves, so the first portion is 0010A4, that's the company ID, and A669D0 is the manufacturer extension. Okay, so this makes only 48 bits. So in between, we have to add a additional 16-bit padding or a 16-bit extra interface ID. So that makes up your 24 plus 24 plus 16 is total 64 bits. Okay? And that's how this EUI64 based MAC address based interface ID or the host portion is made up. There is some more details about this. If you take this MAC address and convert it into binary, so initial numbers comes to be like this, but here it will be changed little bit. It's like a, not 00, here we have 02 because the seventh bit is flipped, and that because of the seventh bit flip, the value becomes 02 here. Okay, are you following this point, guys? See, 1, 2, 3, 4, right? 5, 6, 7. Exactly 7 bit is turned into 1, right? And because of that, it makes 0 to 1, 0. Rest of the things are as we have discussed. Okay. Beside link local address, because link local address works within a LAN or within a point-to-point link, but it will not work beyond that link. If you want to send data across the internet, then link local address is not sufficient. Then we have to use global unicast address like this. In the global unicast address, the first 3 bits are same, right? And after that, we have global routing prefix. So normally it starts with 2, right? So how 2 is represented with the 3 bits? If you calculate in the binary, 0, 1, if you do the calculation here, 4210 8421, and it will be represented as 0010, right? And these values can be 0010 and 0011. If it is 0010, we have to write it as 2, and if it is a 0011, then we have to write it as 3. Are you following this? And this is our uh, first nibble or the first 4 bits, right, for the hex value, right? And then rest of the bits can be anything that comes from our global routing prefix. So these global routing prefixes are given by the INA, right? Uh, so let me show you an example. Let's consider we have a global routing prefix 2000, right? And then we have A as the ISP number, and then we have B for the company. Right? And after that, we have a site ID. It means here you can see 3 bits plus 45 bits. In first hex, this is your first hex group, 16-bit hex group, right? Then here we have A, this is second 16-bit hex group, right? And then we have third 16 hex group, and then we have fourth 16 hex group, right? So I'm representing it like this, right? So this particular portion is your 48-bit global routing prefix. Is it clear? If you have any doubt, guys, please ask. I hope this is clear for all of you. And after this, for first department, we can take it 1. For the second department, 2. Third department, 4. Like this, we can have 2 raised to 16 combinations. Right? So thousands of combinations are possible within this. Yesterday, we were trying to implement the IPv6 address with the help of IPv6 router, but this VMX router was not working as IPv6 router. Right? Now I have made few changes, right? And because of this, this VPC4 got the IP address now. Let me check. Show IPv6. So you can see here, so I got the global scope address 2001 AB1, and after that I have a MAC address based or EUI64 based interface ID. Okay, this particular network prefix I got from the router solicitation message and router advertisement message. Let me show you. Show interface does. And we can see here specifically for GE001 what IP I have here 2001 AB1 colon 1, right? And if I show you configuration, display set options, so here you can see set protocol router advertisement interface GE001. This prefix I have to advertise, right? So router advertisement or RA messages are generated because of this configuration. Otherwise, RS message was generated, means who is a router is questioned from the VPC port, but VMX router was not responding with RA messages. Because of this command, now it's responding back with the correct information. Okay. We can set this IP manually also. This we have set it with the Slack last time around, right? And now we will set it with the static IPv6 address. Let me set the IPv6 address now. We'll get that IP from VMX router first. let's keep it 15/64, and we'll take the gateway. Okay, let's check the IPv6 address. So address is visible. Let me check, am I able to ping to that address? Yes, we are getting a reply as well. Okay. This additional information or additional configuration that we have to do for the Slack, we were struggling for the last practicals and last session. Now this is a information about Slack, like RS, RA message. RS is a router solicitation and RA is router advertisement. Interface configuration. So we have seen this interface configuration. We will do the same configuration on another interface, that is GE000. So let's select the VMX router. And let's go to the configuration mode and edit interface GE00. In our topology, the router VMX router connecting to ISP router is GE000. So we will take that GE000.0. Okay. And then we will do the rest of the configuration, like set family. This time it should not be INET, it should be INET 6, right? Address, and the address that we want to set here is 2001 AB. Let's keep it 2 this time, :1/64. Okay. Let's go to the top of the interface configuration, and let's check the configuration changes. Show compare. This we can commit this. Now we will do the configuration on our Cisco router for IPv6. We have 3725. Yes, here we go. So IP interface break. Here we have IPv4 address. Let's check IPv6 address, and obviously we have not configured anything, so we'll not see anything here. We will configure IPv6 address here, interface F00, IPv6 address 2001 AB2 :2/64, and hopefully this time we should have our IPv6 address visible here, right? Let's ping and test connectivity. Yeah, so connectivity is all good. Let's save, because here we have to run WR command to commit. Okay, so IPs are assigned now on both the routers. Next, we have to create a routing entry. Okay, so how the routing entries will be created: with the edit routing option, we go to VMX router, edit routing options. So whenever we have to make changes in the routing, we have to go to the edit routing option, and then we have to run a command rip inet 6, and this time this is a static route. Okay, and we are going to point out the default route here. So that default route is 0 colon colon slash 0. Okay, this represent a default route, right? And then we have to specify the next hop IP address. So what is the next hop IP address? 2001 AB2 colon colon 2. Whose IP address is this? This is our Cisco router's IP address. I mean this router, because we kept the IP address 2001 AB2 colon colon 2 here on F00 interface, if you remember. Right? That's it. Preference, if you don't specify, as this is a static route, it will go with the default preference of 5. Okay, let's commit this. Let's go to the top, show, compare, and let's commit. With is not required. We'll go to routing options and run a show command here. Rib is not working. Let's try one more time. Let me check the commit check. Invalid rib inet 6. Maybe there is a minute mistake on this. We'll see. This portion I'll test out where exactly it's going wrong, and we'll work out this option tomorrow. Okay, we'll stop here, and this routing options of static routing, and afterward we have to go for OSPF v3 also. That also we'll test out later on. OSPF version 3. So this I'll test on my machine first, and then I'll show you how exactly it works on the VMX router. Okay, then we'll stop here. Rest of the portion we can cover in tomorrow's session.